I'd like to go ahead and invite the members of the first panel up to the stage right now while I introduce the moderator. Dr. George Sowers has 30 years of experience in the space transportation field, working with Martin Marietta, Lockheed Martin, and the United Launch Alliance. He recently retired from his position as Vice President and Chief Scientist of ULA, where his team developed an architecture for fully reusable in-space stages fueled by propellant mined, refined, and distributed in space. He now is joined at the faculty of Colorado School of Mines as part of the newly created graduate program in space resources. So, and our other panelists are joining us. Thank you very much. Dr. Sowers, I'll turn it over to you.
Good morning. Thanks, Ben. So welcome to the panel on LEO commercialization. So throughout the week, we've talked a lot about the commercialization of space. We've talked about organizational constructs, and we've talked about technologies and capabilities. We've talked about investment strategies. But one thing that's kind of been missing is how do we make money in space? I mean, that's really the key to commercialization, right? And for the students in the room, that means that your revenues should exceed your costs. Pretty simple. But through the history of humans in space, there's really only been two ways to make money in space that have been effective. The first is sell things to the government. That's what my former companies have spent a lot of time and effort doing. That's what a lot of people in this room have tried to do. But in turn, the government has to convince taxpayers that it's worthwhile for purposes of national security or national prestige or science or whatever it may be. The second way, which is truly commercial, is communications. We've had a fairly robust commercial market in the ComSat world, primarily satellites in geosynchronous orbit. And it's true commercial in the sense that you can trace the revenue stream back to a consumer, somebody like everybody in this room that wants to talk over a cell phone or do something like that. In the last several years, there's been glimmers of other ways to make money in space, and in particular in low Earth orbit. And we're privileged today to have representatives of 3 companies that are trying to do exactly that. To my left, we have Negar Feher, who is Business Development Director at Space Systems Loral, focusing on small sat applications. In the middle there, we have Mike Lewis from Nanoracks, whose company's done pretty well launching CubeSats and is now embarked on an innovative venture repurposing spin upper stages for use in low Earth orbit. And then down there at the end, we have Andrew Rush, who is trying to figure out, he's the CEO of Made in Space, trying to figure out how to manufacture stuff in space. And so with that, I'll turn it over to Negar, and we'll get a little presentation from each of them, and then we'll get to questions.
Thanks, George, for the intro. Appreciate it. So, as he mentioned, I work in our division that does primarily commercial Earth observation and small satellites. But I wanted to start with talking a little bit more about SSL and our corporate umbrella, which is called Maxar. So I want to start with a video explaining what Maxar is and what we're planning to do.
The interdependence between Earth and space impacts humanity globally. Their connection is vital. Meet Maxar. We're connecting the world, revealing insights, building technologies for tomorrow, and protecting people and our resources. Our combined capabilities have delivered solutions for decades, since man began exploring space. 4 companies at the heart of the new space renaissance, accelerating innovation at the intersection of what's new and what's possible. Creating together what no single company could alone. Integrated solutions that harness all the power and promise of space. To build a better world, here on Earth, the nexus of the new space economy. Maxar.
All right, so hopefully that gives you a little bit of insight into who Maxar is. So now we are a business unit of Maxar. Just wanted to make sure everybody understood what that meant. And I believe when we acquired Digital Globe and Radiant Solutions and became Maxar, we really were able to offer these integrated, end-to-end solutions. We can do anything from, build a satellite to build a ground station, to take that data and do the analytics on it using Digital Globe and Radiant Solutions and deliver it directly to the customer. So it's like a one-stop shop. I know turnkey solution, end-to-end solution is like a phrase that's a lot commonly used, but that's something that I'm super excited about. So if anybody wants to talk to me more about that, I'm happy to talk about that. And next, I want to tell you a little bit more about what we do in our commercial Earth observation group and what we do in terms of small sats. So I'll show a video for that too, and then talk a little bit more. So that was just a brief video to tell you about a little bit more about what we do on the small sat side. And another thing that I wanted to just touch on briefly was a concept, a program we have. We call it Simplifying Space, where we like to partner a lot with startups from the very early ideation phase all the way on to when they're on orbit and working on delivering data to their customers. So what we try to do is take advantage of Maxar and the fact that we can do these end-to-end solutions and offer advice, kind of similar to the mentor-protege relationship that we heard about in our keynote this morning. Something similar to that is something we're offering to a lot of startups that we're working with. So if any of you are in the audience who would like to talk to me more about that, I'd be happy to explain what we're doing there. In general, the small sets that we build are used for a variety of applications like you saw in the video. We do Earth observation, remote sensing, and even build small sets that would go into deep space. And the last thing I wanted to touch on was space infrastructure. Another area that we're working on a lot is space infrastructure because we believe that it's an area that needs a lot of work. For example, imagine if the airline industry, if you flew somewhere and every time you landed, we just threw the airplane away. That's the way the space industry works today. We build a satellite, we launch it into space, and then after a while, You just throw it away, and then we send another one up there. So we're trying to change that paradigm. We don't want to build resources that go to space and then just get thrown away, the same way the airline industry operates. So in that regard, we're building satellite servicing. So we're building 2 satellites right now that can go up into space, can refuel other satellites in space, can move them around, can build satellites in space. And we're partnering with people like Nanoracks to build habitats in space that reuse stuff that are already in orbit to convert them into human habitats. So that's an area that we're working heavily on, both in LEO and in GEO, with 2 programs that we're doing not just tech demos, but actually putting services up there. Imagine like AAA in space. So instead of having, this model where you launch it up there and you throw it away, now you have AAA in space. So you just call us up and say, hey, my satellite needs fuel, or, the solar array is not working, or I need a new payload, or, oh, my business plan wasn't quite right, I need to move to a different location. And we'll be able to do that with our robotic servicing satellites. So I'm very excited about that, and changing the space paradigm and adding space infrastructure into the economy. So that kind of answers a few of the questions that you wanted, but we'll let our other panelists go.
Great.
Thank you.
Thanks, Negar. All right, Mike, you're up.
Thanks, George. Thank you, everybody, for being here. Negar, that was great. Thank you for the shout-out.
Yeah.
My name is Mike Lewis. I'm the CTO of Nanoracks. I do want to take a second and thank George for his work that he's done, that I'll talk about in a sec, that gave us a lot of precedent for what we're doing today, where we're at today. Also, thanks to the Space Frontier Foundation, like the now new next Nanoracks. They're just all Negar. We got N-words everywhere. Oh, goodness. All right, so sorry about that. So next slide. Do I have a clicker? Thank you, guys. So my company is Nanoracks. We are still a small company, but we think big. Our vision is a future in space where we have commercial space stations and habitats populating the solar system. Negar mentioned some of that we're looking to reuse some of the facilities that are up there, and just generally change the paradigm towards reuse of things. Today, we're the only commercial space station company, which we call ourselves, with existing customers, and we have a pathway to operate in commercial platforms in space with realistic price points. So that's you'll see that's kind of a theme of this panel. We're hub and spoke, whatever that means, and really, we like to say we're customer driven. We're founded back in 2009 on the premise of one day owning and operating our own space stations. So a lot of our platforms and technologies that we've developed have all been working towards that goal. We look at ourselves as a group that's democratizing space, basically lowering barriers of access to customers, not only in America but around the world. Relatively low cost. We do that by standardizing hardware and trying to have hardware that a researcher would have on the ground, also have it in space, so it's not a full development just to be able to work in space. But primarily, we're for the customer. We follow our customers. We've had a great amount of success because we've listened to them. People come to us and say, "Hey, can we do this?" And then we say yes, and then we get terrified, and then we make it happen. So about that standardized hardware. So a couple pictures here. Basically, our service lines are filled with standardized research platforms. We have a couple platforms on orbit that are kind of plug and play. Our most generic platform we call a frame. Basically, we put a computer up in space, and this allows researchers to plug in like you would a USB peripheral on a laptop on the Earth. Just plug it in, and we're able to remote desktop to this frame and run an experiment. And we found that this has incredible applications, and we found that there's a lot of side benefits to that. Not only are we seeing great experimentation in a lot of different branches of science, but we're also seeing a lot of engagement at the education level. This is a platform where students can build things. It goes in, it's low risk, it can be done in the course of a school year. Some of the other pictures shown here I'll get into a little bit, but we have other platforms on the station, and we have platforms that are also on other vehicles. And I'll show you that in just a sec. Our ecosystem primarily centered on the ISS. We also have access and opportunities with the PSLV. I show a picture of the airlock module here. I'll talk about that in just a second. But we're also the integrators for the Blue Origin rocket for payloads on the New Shepard, and we have a MOU with Moon Express. You see the R2D2 in the corner there. We have a lot of visions for additional international platforms, and everything moving from LEO beyond. So this place we like to talk about how do you make money in space. We've been pretty successful in developing our company organically. We've been able to not take gigantic monetary risks. We've been profitable, which is kind of wild. We invest our own capital back into platforms, but we don't do it just because we want that or because we think it's cool. We move with the market. We kind of make sure that we're answering a call for a researcher or for a commercial application. We have a lot of customer support and dedicated technical account managers. Really, like, I have as many mission managers as I do engineers at the company, and kind of, it's weird. It boils down to just a regular business practice, right? Like, somebody wants to work with you because it's a pleasant experience. Not only we're providing access to a really unique market, unique real estate, unique places to go, but if you don't like dealing with the person, you're going to find another way to do that. So a big emphasis on our company has always been customer service. We also have been expanding this to other parts of the world. We got a European market that we view as untapped, and we've opened a European office, working with Thales Alenia on our airlock, which I'll show in just a sec. But we found that there's difficulties, but they all can be overcome, and you really just have to treat it like a business, treat people like people, and you'll find success in that. Some of our customers, we did this really fun experiment where we flew, it was a terpene extraction experiment early on in Nanoracks, and terpenes are a constituent component of whiskey. And the whiskey company was Ardbeg, and their parent company was Louis Vuitton. And I used to put Louis Vuitton on this because it used to get a lot of questions, like, what do you do in flying purses? But as you can see, key to this, we put ESA and NASA are both customers. So it's a unique thing. You used to be, you would go and say, hey, I would like money for this. What we've been doing lately is NASA comes to us and say, hey, we want you to do this for us. The NASA system in a lot of ways is burdensome. Many of you guys have developed things for space and for ISS in particular. And NASA has identified that we can put their product, their payload, whatever it is, through their own system faster than they're capable of doing. So it's interesting, and it's an interesting model for business in space. As of 5:41 Eastern tomorrow, we're going to be on 34 launches to date. We've had a lot of nano experiments, nano this, nano that, but also a lot bigger stuff. And this doesn't actually count the Blue Origin launches, so we're higher than that. We've done a lot of work in space. We recently had the national labs run some numbers for us, and to date we're over 50% of the national lab allocation of payloads to the space station. So very proud of that. Picture from last week, not yet publicly available. You guys may have seen this. This is the Remove Debris satellite. It was developed through a European Commission. there's a consortium of companies throughout Europe that developed this technology. It's a single satellite, looks like a Borg ship. It's got 4 different experiments on it that are all intended to clean up debris in space, to advance the technologies there. But anyway, it's a great picture, I thought. And our deployer there, you can see on the end of the robotic arm, is the Cabra deployer, one of the standard platforms we have in space. Another one of our platforms you guys are probably more familiar with. This is a CubeSat. We call this a double-wide CubeSat. The lesson there: be real careful what you name your deployer. Holy cow, it sticks. Yeah, I was kidding around. I was like, well, it's double-wide, and then. So we also have a deployer that's twice as tall, right? So it's double wide twice, and I call that the tall boy. And guess what? The NASA Opnom, it's tall boy. Yeah, it's ridiculous. Don't get me started on Ixion. Oh goodness. All right. So there's a lesson there. If you learn nothing else from my ramblings here, be careful what you name your stuff. Interesting platform we have going here. The external Cygnus deployer. I like to talk about this because it's an example of sometimes people don't know what they want until you tell them. We approached Orbital a couple years back and said, hey, we would really like to put some stuff on the outside of your rocket. And they said, oh, well, why? The primary mission of this vehicle, this is a Cygnus vehicle shown here, is to go to the space station, supply it with, resupply things per the NASA contract. And I said, well, but it's this great spacecraft that can do other stuff. So they said, oh, well, okay, we're interested. And so through that conversation, we figured out that there was this nice little location. You can see the white box is my box, and it's full of satellites. And we worked through that system with this big company. Here's my little company working with the now Northrop, enormous company, to put a capability on this spacecraft that was not there before. Right now, the OA9 Cygnus is still berthed to the station, but soon, next couple weeks, it's gonna unberth. And one of the fun parts about this is it goes to a higher altitude after it unberths and does the deployment of satellites. So it's great for us because our customers love the additional altitude. They get additional lifetime. But it's also a great example of how, us, the NewSpace, the small companies, we can work with these big companies. We can find a way to do it. We just have to show we don't, blow up the rocket, basically. So, just 3 more slides, I promise. I like to talk about our Bishop airlock. So this is in development right now. It's our next generation facility. It's the first truly commercial module for the space station. We're going on Node 3 port here. It's a science airlock that we identified a need for. You may or may not be familiar with the airlocks that are currently on space station. The Japanese airlock in the GEM module is a wonderful resource, but it's oversubscribed. And we identified that a couple years ago. We said, goodness, there's a long line for people to use this. And so we said, well, heck, let's build our own. And before we knew it, we asked around, and people thought that was a good idea. And we got a Space Act for this node, and I designed it and got a patent and all this junk. And then it turns out that we had to make it. So this is going up on SpaceX 19. It's going to be enabled the end of next year, which is, both exciting and terrifying for me. The metal is being cut and wires are being run and everything. So it's going to be a capability that the space station has that we've self-funded. So we're really proud of that. Going forward, I've talked about a lot of our programs, but what Negar was talking about, the Ixion project, formerly called, is shown in the upper right, the Independence one. This is our plan. We want to reuse some stuff. There's a lot of great things that are developed and that are thrown away. They throw away the airplane. In this image, we're conceptually looking at the idea of a Centaur, which is the upper stage of an Atlas V, it's already almost all the way there to a space station. We just want to do a couple more things to it, and using folks like Andrew's company, NewSpace, Negar's company, SSL, we're going to outfit these things and make them fully functional space stations up there. So, cool. Thank you guys for entertaining me. Nobody took the mic away. And thank you again, George.
Thanks, Mike.
Yeah.
All right, Andrew.
Thank you, George, and thank you to the Space Frontier Foundation for having me. This conference actually means a lot to me. It was the very first conference that I attended in the industry, and I saw at a late night party, much like the party last night. I saw a wake for Constellation, and of course now that lives on in different versions. But one of the things that I feel like we've consistently talked about for years at NewSpace and at lots of different conferences is reducing the cost of launch. There's amazing innovation in the launch industry right now, right? Like everybody gets excited watching the Falcon Heavy demo flight and watching those two boosters come back and land, but I'm going to say that that's not the point. Rockets are not the point, and space stations are not the point. What we're seeing there is pretty amazing, but the point of everything that we want to do here is actually what we put on top of the rocket and what we put inside the space station. And ultimately, I think that for us really to see humanity sustainably living and working in space, we need to expand the pie of what we're doing in space and ultimately expand the launch pie and expand utilization of space stations. And for us at Made in Space, as the name of our company kind of previews, we really think that manufacturing is that sort of step change that will open this final frontier for us of space and let us do really truly amazing things and really provide a driving force that is not, as George you mentioned earlier, is not convincing the government to do things to fund activities. And specifically, there are kind of two areas of in-space manufacturing that we think are really transformative. And these are areas that I'm proud to say we're doing real work on. It's not just pretty PowerPoint. Sort of like what Mike was saying, we have to go and cut the metal and build it and make it work. And those are doing in-space manufacturing for use in space, making space-based assets. And then the other piece is doing in-space manufacturing of products that we're going to use back on Earth. And both of these are really, really important, so I'm going to kind of take them one step at a time. So in-space manufacturing, making satellites, augmenting satellites, repairing them, is an area that 10 or 15 years ago I think was firmly in the kind of NIAC regime, and with some folks doing some great work and a little bit of some groundwork, but we're really, really excited and proud and a little bit humbled that that NASA and other government agencies have put a lot of firepower behind taking this technology from the drawing board, from pretty pictures like this, to actually soon on orbit demonstrations of this technology. We started with doing 3D printing on the International Space Station. In a variety of materials, some materials that can survive out in the vacuum, some materials that are just like ABS, like Lego plastic, and now we've demonstrated that now in thermal vacuum chambers, and we've done robotic assembly of those things, and our friends at SSL have some really great programs in similar areas, but this right here, this image though, it's very It's just a pretty PowerPoint picture. This is the future that we're building. We're building a future where we have some really incredible, just different assets that we're able to put up and put up, from very small packages, being able to provide a huge amount of power on small sats, being able to provide very long baseline, very long baselines or things like SAR, being able to provide really big apertures or reconstitute and reuse, things like ESPA rings, ultimately to provide more capability per dollar. Which, to go back to talking about launch, like when we talk about reducing the cost of launch, really what we're talking about excluding the human perspective is, hey, how do we get more capability in space for cheaper? So if I can reduce the cost of a deployable boom and make that thing also lighter, I've actually been more effective in reducing that dollar per capability delivered on orbit than if I had a really cheap launch vehicle. So the other area that that at Made in Space we push on a lot is that manufacturing of products in space for use back on Earth. And this is an area that LEO is just perfect for doing operations in. And it's also what I believe very strongly, one of the first steps that we're going to take that will expand the pie and push, and be a forcing function for, people sustainably living and working in space, producing things, in space and bringing them back down to the ground to the economic engine of humanity and, generating profit that way. I'm really excited for, one day for asteroid mining and completely space-based economy. But I think this is a necessary first step, that first we go and we leverage the space environment to create interesting products, and then we come back and sell them back on the ground. And so the space environment, from a processing perspective, does a lot of really cool things, has a lot of cool properties. In particular, being able to sort of take gravity out of the manufacturing equation. And for going all the way back to Apollo 14 and maybe even earlier, there has been research on processing stuff in space and how that helps and how that changes material properties and actually makes things more valuable in some cases. So there's been a lot of research on optical fiber. There's been a lot of research on metals and manufacturing semiconductors, and even now in bioprinting and creating vascularized tissue. So at Made in Space, we building on the success of producing the very first 3D printers that worked in the microgravity environment, we said, hey, how can we apply this expertise elsewhere? And we arrived at actually manufacturing this optical fiber called Z-Blan in space, which has a much wider transmission window, much lower attenuation than silica fiber, which is the optical fiber that we all know and love that runs across the Atlantic, and some of us are fortunate to go to our homes and provide great connectivity. And so we worked on this. We've been working on this project for a couple of years now, and we were quiet about it, and then eventually kind of came out and said we were doing it. And I'm actually proud to say that so this is a picture that of the unit there. Actually, both the commercial units we have on station, the 3D printers behind the astronaut's hand, and then that unit above is our one of our optical fiber manufacturing facilities. So this is happening right now, that we're manufacturing product in the microgravity environment, that because it was manufactured there, it's got use and value for folks back on the ground. And it's it's early days. It's a very exciting time. And I really look forward to that vision. I think it's going to be here before we even know it, where we're doing more things in space and filling up space stations and buying more rocket launches than they're currently being sold today, because of things like in-space manufacturing. Thank you.
Thanks, Andrew.
Thank you.
All right, well, I'll get us started with a couple of questions, and then we'll turn it over to the audience. I'm sure you guys have lots of questions for our panelists. So we've talked a lot about creating a robust economy in space and in low Earth orbit and cislunar space. To grow an economy, the one system we know that works is the free market. And the foundation of the free market is the consumer. So eventually, if we're going to make money in space and if we're going to grow the economy, we got to figure out how space activities deliver value to consumers on Earth. And so I'm going to put the panelists on the spot to, describe for your business, to what extent does your revenue stream trace back to taxpayers? Taxpayers, fund all of the government activities, and it may be a torturous path. It may go through the National Science Foundation for a research payload, or through NASA, or through, the DoD or something like that. But, fundamentally, paying taxes is an involuntary transaction, right? We don't voluntarily pay taxes. We do it because we have to. To grow the economy, you want to rely on voluntary transactions where consumers are buying stuff that you're providing because it provides value to them. So on the spot, give me a percentage and maybe describe to what extent your business model relies on government, taxpayers, or consumers, and then what can you do to increase the share that's truly commercial that's coming from consumers? We'll start with Andrew.
So I think I've said this publicly a few times, but without NASA, without the government, Made in Space would not exist as it does today, and we're extremely grateful for that. In the beginning, we started from the SBIR program, and built up from there. A big component of SBIR is saying, hey, figure out a way to commercialize this. As was mentioned earlier, get your wings and get out of here. We've taken that to heart, and so the second 3D printer that was ever flown to space was a commercial unit that we own and operate. And we've built on those successes. We do a good amount of work still, with this kind of I hope a virtuous cycle of small development contracts and then larger development contracts and flight demo. But always with an eye toward saying, okay, once we do that flight demo, that's going to be our proof of potential. And we have commercial customers that are interested in that will be paying for that once we're on orbit. The Z-Bland project is actually a little bit idiosyncratic in that we just completely self-funded that project. So the profit that we generated, and then some financing that we secured through Space Florida was used to actually build that. And so our commercial revenues have grown year over year. And our goal is that in the next couple of years, the majority of our revenue will be driven by commercial, both things like Z-Bland as well as products like our Archinaut in-space manufacturing and assembly technology.
Great, Mike.
Yeah. So. No, that was a great answer, Andrew. I actually want to take a second and compliment the fiber optic work that they're doing. I looked into doing that a number of years ago, and it's really hard. So I'm impressed how it's working. It's a perfect example of something that you can only do in space. So to answer your question, George, what percentage of our business is coming from subsidy or whether a tortuous path or direct from the taxpayer. So a lot of our experiments are, almost 100% of our experiments are funded, commercially. They're either there's on one end there's procurement through the Air Force, things like that, but then there's educational groups like there was an elementary school that I think had a GoFundMe to fly things. So at that level. Very little percentage of the taxpayer money. One area that we've identified, though, that we are being not necessarily subsidized, but we're taking advantage of, is the UpMass. Right now, our business model includes free rides to space, effectively free, through use of our Space Act agreement, which provides us access to the space station. Now, I don't feel guilty about that because that's available to everybody, but as we look forward and we develop our business plan further, we have to look at the case in which we're paying for every ounce to get up there, and we still believe that business case closes, but it is something that we're being subsidized with.
Yeah, and let me be clear. There's nothing wrong with making money by selling things to the government. I mean, I spent my entire career doing that.
Right.
But if we want growth, government budgets are essentially flat, right? If not declining. I mean, the mantra, the adage in NASA a few years ago was, flat is the new up. I congratulate NASA on getting a couple of bumps in the last couple of years, but I wouldn't count on that continuing. So if we want growth in this industry, we got to figure out the problem of how to deliver value to the broader economy and not depend on governments. If we depend on governments, then we're not going to go, the market's not going to grow. It's going to stay flat like it's been for the last, 40 or 50 years. So that's why it's important. It's not a value judgment. It's how do we crack the nut to get into the broader economy?
No, and I agree, and I think that our philosophy in Nanoracks is to use that. Let's do as much basic science as we can. Let's identify some areas where we can commercialize things that where we're using our current facilities to develop things that are unique to that microgravity environment.
Yeah, and in the best cases, you can leverage government funding in the short term to break into the broader economy in the longer term, and that's what NASA tries to do with programs like COTS and others, SBIRs, and some of the others that we've talked about. So, Negar?
Yeah, I think that's a good question, but just to elaborate further on what you just mentioned, I think we're actually extremely fortunate to be in the U.S. and to have this government backing for a lot of these projects. I agree that Made in Space, Nanoracks, and even our space infrastructure business that I mentioned earlier wouldn't exist if it wasn't for the likes of NASA and DARPA, et cetera. So I want to actually applaud the government for having those programs to help initiate that and give people the wings to be able to fly later. But I do agree with you that eventually these companies do need to fly away and be able to stand on their own 2 feet. I also wanted to make the point that it's really important to support these companies as they're growing up. I like to say that, just another nod to the simplifying space model that, government supporting them to do the research is important. And then, commercial companies need to come and, either through a mentor-protege relationship or something else like that, start adopting a lot of these technologies that are developed and commercializing them. So I think it goes both ways.
Okay, great. So questions from the audience? In front here?
Yeah.
Somebody, we got a runner to...
Here I am, yeah. I'm Alan Boyle with GeekWire, and I wanted to ask a little bit more about ZBLAN and whether you've gotten any samples down. I think the idea is that it doesn't crystallize as much as silicon. Maybe you could explain what the advantage is, whether you've been able to test if that advantage really has come through in samples, and what you think the first applications might be.
Yeah, thanks for the question. So from hopefully a 30-second explanation of why we make ZBLAN in space. So ZBLAN is a fluoride-based optical fiber, and it's actually 5 different compounds, and it creates this beautiful crystalline lattice, theoretically, when you pull it, when you manufacture it. But when you pull it under unit gravity, the lattice doesn't really set up well consistently, so you get a significant number of microcrystals that form in the fiber itself, and in each one of those domains, you lose like 4% of the light, and it just ruins the attenuation of the product. Now, theoretically, depending on the wavelength that you're at, ZBLAN will actually have an attenuation or a signal loss that's 10 to 100 times better than silica fiber. So obviously, that's really great, but we get these microcrystals, and that ruins it. NASA, through a series of parabolic flight experiments, demonstrated that if you do this pulling in microgravity, that crystallization is suppressed. So you get like one big awesome crystal instead of a whole bunch of little chunky things. So we get better attenuation. So we're actually launching the third flight of our kind of pilot factory on CRS-15, which, as Mike mentioned, hopefully, knock on wood, goes off tomorrow morning without a hitch, and we'll do some additional testing and manufacturing there. It's been a really good couple of runs. We've been dialing a lot of the hardware and gotten and actually pulled some fiber. manufactured some fiber on it and have gotten some, and it's been really really inspiring to see that happen, and it's been and have some of our hypotheses confirmed about it pulling really well on orbit. I can't really talk more about that, but yeah, we're progressing with that and starting to look at and starting to really seriously get into what the next pieces of hardware will look like, and how we'll build those up and go with those. From a customer perspective, the sort of like medium to long-term customer is long-haul telecom, being able to provide significant amounts of bandwidth and much lower response time, communications lines. But it turns out there's a lot. One of the reasons that Z-Bland's really, really attractive is that there's a current market right now for the sort of poorly manufactured, poorly Earth-based manufactured version of it, in things like fiber lasers, supercontinuum light sources, and several other scientific applications. So, and we're actually, we have a subject matter expert in a company called Thor Labs that is one of the world's experts in manufacturing Z-Bland terrestrially, and so they're a good avenue to those early stage customers.
Yeah.
So
Sorry, to jump in on that, my earlier compliment, if it's okay, George.
Sure.
So this is a particular challenge, and we figured this out recently that even doing basic science is tough. So you guys might be familiar with the truck stops. There's rock candy. It's like a stick, and it's got little crystals on it. So I have an educational branch of our company, and we said, okay, we're gonna make an experiment you could have in every classroom, and then we're going to do it in space. And we figured out rock candy, right? This is going to be easy. You mix sugar and hot water, and then you put a stick in there, and it turns into crystals, right? Works on the ground 100% of the time. Flew this bag up to space with a bunch of sugar in it, and the astronaut hooked it up with hot water, put a stick in it. Like, oh, all right, it's going to happen, right? No crystals. Like, seriously, no crystals. Like, not even like, the ones I planted in there to guarantee results. So it actually is super interesting because then you get into the basics of why is this happening, what is this, and it shows how fundamentally things are different in microgravity, and things like making fiber could be this. It could justify the entire everything that's ever been spent on space, just if this works.
Yeah, but now I don't think I want to go to space because there's not rock candy.
Drink a bag of sugar water. That's about.
So I'd like you to, this is to Andrew and Mike. I'd like you to go 10 years into the future because, Mike, you're talking about repurposing space stations. You're talking about manufacturing in space. Give us your vision, your joint vision, developed right here maybe, for what it's going to look like when you are at scale producing this fiber optic in space, to include how you're going to bring it back down. So just go with it.
All right. Okay. First, we fly a repurposed Centaur, built with robotics from SSL, outfitted with made in space components and a couple other things. We get this as a free flyer, fully robotic, so that you're not subject to the same safety considerations as you would for manned space flight. Then you have production in there. We have these modified machines using the proprietary stuff that Made in Space has developed. We build spools of that, and then we have to develop a return vehicle, right? Something like, it's the branch of SDT. They made the little return vehicle. Yeah, terminal velocity. Yeah, it comes back in that one. And then somebody swims out in the ocean and grabs it. And step 3 is we make money, right?
Hopefully we made money at the beginning.
Yeah.
Deposits are good.
You're right.
Yeah.
What do you think?
Yeah, no, I think that's very that's a great sort of implementation. But like broadly, like 10 years from now, our sort of fundamental goal, the thing that we sort of say we want to do is I want to see I want to see factories in space, and I want those factories to be the anchor tenant for things like Independence and Independence One, like that. And that's really, we want to be the sort of grocery store. And then you have all these, and that'll not only enable that whole strip center, as it were, to be there, but it will enable other smaller stores and enterprises to also be going and doing things. Because we're really, one of the things that we talk about on a fairly regular basis is the importance of the ISS, the importance of the ISS National Lab, and that because it lowers the barrier to entry for folks like us to go and like try. We're a small company, and we're a couple $1 million of our own money into this fiber optic project. But for the International Space Station and the National Lab and NASA, that would cost like hundreds of millions of dollars to try to do that, and we'd have like one shot at it, and it would be a much more austere, difficult environment to do that. So 10 or 15 years from now, I'm really, really excited to see, to be the anchor tenant, but also to see other people be able to kind of, repeat that same paradigm of, hey, I can put a little bit of money in, do something cool, and then scale it. We probably will need something more like at scale. Small return. Small return is really, really important, and there's not enough of it out there. So anybody who wants to work on that'd be awesome. But we also probably get to the stage where we need to be filling up whole Dragon capsules with material and bringing that back.
All right. Thanks, Andrew. So we got about 5 minutes left. I'm going to ask a fairly, a little bit loaded question, maybe, political question. The elephant in the room in low Earth orbit is the ISS. You've talked about how it's enabling for some of the stuff, that as a national lab, it gives you, low-cost access to, where if you had to pay the whole cost yourself, you may not be able to afford it. But it costs the taxpayers, roughly $3-ish billion a year. The administration is starting to talk about life after ISS, and is examining different options for commercialization or full retirement, dropping it into the ocean. I've been an advocate for boosting it to a long-lived orbit for salvage in the future. But if you could give advice to NASA on what to do with the ISS and how to transition it, what would that advice be? I'll start with Negar. You've been quiet for a while.
Such a loaded question.
My advice to NASA would be to put it out for bid to the commercial industry to buy it. Anyone, it's like for sale. See what happens.
So this is a loaded question because, I think as a commercial company that's trying to build our own space stations, I think the obvious answer would be like, well, we'd try to buy some. But when you start looking at it, you realize there's a lot of would you want to buy? The liability alone, the insurance. Say you've got a real old vehicle up there and something breaks. Do you go after the Teledyne Brown that built that thing, or do you go after the Boeing that verified it, or the NASA that owned it, or do you have to self-insure all of that? It's complicated. I think if I could recommend something to NASA, I would recommend they continue what they're doing, is where they're identifying areas that can be handed over to commercial companies. Certain facilities, say a freezer or a glove box or something like that, and take that overhead off of NASA while still maintaining ownership of the vehicle itself. I think.
George, thank you for the question. I think there are a lot of really smart people that have been thinking about this for a long time, and I think that it's pretty forward leaning from the administration to kind of put a date, to put a date out there to basically kickstart the conversation, which I think folks like us actually welcome, because it was previously like, hey, this is a thing that's coming and we're kind of worried about it, to, oh, now we're really actually having the conversation, and I think that's really, really, really great. The two things that, humbly I would recommend on this front, there's two things. One is a capability-based transition. It is something that this industry has seen on multiple occasions where we've had a gap. Whether that be the gap between Apollo and shuttle, or the gap between shuttle and commercial crew. We have these gaps, and gaps are momentum killers. If there is not a commercial platform in space when direct federal support of ISS ceases, or there's not some alternative, you will smother much of the momentum and innovation that folks like Nanoracks and Made in Space and many others have been working really hard on. And I think and we have the opportunity to not smother it. So I think if we say, hey, let's have a transition that occurs once there is an existing capability, whether that's commercial ISS or a free flyer or a module attached to ISS that can detach. It comes in many different ways, many different forms. But we should have that. The other recommendation that we would make is to kind of going back to what I said at the beginning. Space stations are cool, but they're not the point. The point is what we do in them. So we would encourage the active support of increasing demand, of increasing activities that are doing new and interesting things on space, in space, and using, human occupied, human tended, or robotic platforms. What this means is what does that mean? It means let's have really strong pharma high throughput research facilities that we build for station and then transition over to things like Independence. Let's have manufacturing of not just Z-bland, but the whole wide gambit of materials that we could do. Let's experiment and let's support the experimentation and the scaling of that. And I think there's even an opportunity to support support things like space tourism, because that's actually one of these things that we used to talk about a lot, and now we're like, yeah, it's kind of there, but will likely be a recurring revenue stream for commercial platforms. So those are the things that we would recommend, but of course there's a lot of really, really smart people out there thinking about this, and our ideas, they probably come up with better ideas than we do.
All right. Thanks, everyone. I want to thank the panelists. If you still have questions, I think we have a break coming up, right, Ben? And you can ask us then or them then. So round of applause.